Yesterday, we had the announcement of nearly 20 nations announced that they are committed to tripling the global capacity of nuclear. And that is unprecedented. And this global initiative, so we have 50 delegates from around the world who's going to be joining us for this youth program. So all throughout this week and the following week, we're going to have sessions between 12 to 2 highlighting all of these youth. So I encourage you to come, hear from them and their journeys. A lot of these individuals are volunteering their time or maybe are an engineering background. So this initiative is launching, and we're here to say that nuclear is part of the equation, and if we want to do a clean energy transition, it's not going to happen without nuclear energy. And we're here to discuss it and talk about maybe some fears that people may have, but also the bright, bright future. And I think it's great that we're here in the UAE where they have a beautiful nuclear plant that will be supplying nearly 25% of their electricity needs.
And I'll add on what you said. You said
Yeah.
nearly 20 have signed up to the pledge to triple
Yeah, what's
nuclear
the
capacity.
number?
It's gone up, since the first announcement. There's new countries that have arrived, and we expect that number to carry on going up as we keep on spreading the word of nuclear. And then also, that's the pledge this COP. There's also conversations to be had of future COPs.
Yeah.
This pledge very much, I think the idea is around electricity use. But there's conversations to be had about nuclear for heat, for industrial heat, district heating,
Right.
but also transport use in sort of international freight. There's plenty that nuclear can offer for
Yes.
the transition to net zero.
Right, and I think we've seen commitments for, let's say, renewable energy and other commitments to meet these climate goals, so let's see how far we can get. And this is, to remind everybody, this is the most attended COP of all history. Nearly 70,000 delegates will be here spread out in the green zone and the blue zone. So I encourage you to check around, make friends, and really see how we're going to actually get this clean energy transition done. And we're here because the nuclear piece has been neglected for far too long.
Great. All right, this is the youth session, so
Right.
It wouldn't be the youth session without introducing all our youth. So one at a time, we'll get you to come up, take the microphone, introduce yourself, who you are, where you're from, how you got into nuclear energy, and what you're looking to get out of COP. So without further ado, address.
Hello everyone, I'm André Fuistiano. I'm a physics engineering student and I have created Nuclear Vision Portugal. Nuclear Vision Portugal. Hello.
Yeah.
Yeah, you got that? Nuclear Vision Portugal? Nice. Okay, let's keep on. So, how did I get into fusion or nuclear energy in general? So, I've always wanted to work in fusion, nuclear fusion, but recently I thought, well, nuclear fusion is not yet working, and we have this option, which is fission, right, ready to go and to deploy to reduce carbon emissions effectively. And we've been doing that, but I believe we can do it much more because, like in Portugal, and this is one of the reasons why we started the group. In Portugal, we don't include nuclear in the conversations of the decarbonization. And so we need to break the taboo and bring nuclear to have a place in the discussion. That's our main goal right now. Thank you.
With André, I co-founded Nuclear Vision Portugal. Our aim is to start the conversation all along Portugal about how nuclear can help us decarbonize and have a great energy mix. It would be great to live here and have Portugal sign the pledge one day. It will be the best thing we could hope for. Thank you.
What's your name, by the way?
Rodrigo.
Hello everyone, my name is Aurora. I'm an 18 years old high school student from Italy, and I'm an admin and content creator for a science outreach page called Giovanni Blue. I started this activity because I wanted to inform my peers in a right and correct way about nuclear energy. And I'm also a member of Nucleare Ragione, which is an Italian committee that brings together university students, professors, and people who wants to support a correct information about nuclear energy. That's why we feel it important, and because we see the key point of nuclear energy in climate change, and we want people from Italy to understand it in a correct way. Thank you.
Bravo. Charlene? Quick shout out.
Good afternoon, everyone. My name is Dr. Charlene Smith. I'm a nuclear engineer. I'm originally from St. Catherine, Jamaica. And I got into nuclear energy after doing several years of solar energy research and not really getting anywhere in terms of trying to pursue my goal of having firm, clean baseload energy for my island country. And so after I did that research, maybe it happened by fate that I was introduced to a nuclear physicist who also happened to be from from the Caribbean, St. Lucia. And then I just pretty much jumped down a rabbit hole of nuclear energy, got my master's in nuclear engineering, PhD in nuclear engineering, and I'm now in the industry. Here we are. For COP, I think what I'd like to get out of it is try to network with as many people as possible to help to build human capacity by introducing engineering disciplines that are not typically offered for study. For example, in Jamaica, we only have five engineering disciplines that are studied. Nuclear engineering is not one of them, but Jamaica recently decided to pursue nuclear energy as a part of its energy mix. And with that, I've launched a pilot boot camp that serves to address that need to introduce nuclear engineering as a technical discipline so that we can start building human capacity from the K through 12 level, but also at the university level.
Bravo.
Nice seeing so much people that they come here to listen to the nuclear corner. I'm Matthias. I'm from Norway, from Oslo. So my journey into nuclear activism has been a roller coaster. My first year, all my time in school, everything I heard about nuclear was negative. All my teachers, my school books, the media, newspapers, the discussions, nothing positive, everything negative. Then at high school, I took physics, mathematics, and then I started to understand how nuclear really works, and that piqued my interest. So I was part of some environmental organizations, and then when I asked them about nuclear, it was kind of taboo. You couldn't discuss it. So then I figured I should start my own environmental organization. So together with some other people, we started a pro-nuclear Norwegian climate organization. And the last 2 years, we've gotten 600 new members, which in Norway, a small country, it's a lot. So our approach is multifaceted. We have events all over Norway where we have demonstrations. We attend international conferences like this one. We all the time get invited to political parties, organizations that invite us to hold presentations about nuclear. We have also gotten students for nuclear in Norway, so we have like student wings that are part of our organization. And last year we did an event where we tried to get rich people together to mingle. And then a few months after that, some of them started a Norwegian company that wants to build privately funded nuclear in Norway. So things are happening quite rapidly. The public opinion is changing quite rapidly from almost everyone against to now around almost a majority. So I would like to thank my help I've gotten from Stand Up for Nuclear, from the international people that have helped us in Norway to bring along the nuclear debate to Norway. So thank you for having me, and thank you for everyone here who's come to attend our nuclear event.
Thank you. And part of the youth movement isn't just here. There's much larger youth movement than what you see here at Net Zero Nuclear. So Paris is in charge of the Stand Up for Nuclear movement, which attracts a youth from around the world. I'll let you introduce it.
Yeah, so part of the 50 delegates is many of them we've grown to know over the years through the Stand Up for Nuclear Network. And Stand Up for Nuclear is an initiative that basically is we advocate for the protection and expansion of nuclear energy. So whether you have a plant that needs saving, or let's say your country's interested in having nuclear, we are basically working with students all the way up to retirees or people in the industry of how do we get the good message out about nuclear energy? How do we talk about it? And how do we do it in a sincere way where we do acknowledge that there's fear and lack of information around nuclear energy, but also that it is such a beautiful technology, and if we want a bright future with clean energy, nuclear is the key. So we do that through events, demonstrations. So many of the advocates that you will see if you guys attend our panel sessions between 12 to 2 every day, people from around the world. We have Italy represented, Spain, we have Norway, we have Denmark, we have in Brazil as well. So we have many countries that are coming out in support of nuclear, and they get to tell you about the work that they've been doing.
Great. I see there's a bit of a crowd building.
Yeah.
And you're here to speak to the youth. So are there any questions from the crowd to us youth? So you've heard Norway, Portugal, Italy, Jamaica, US, UK. Does anyone have any questions to us youth about what we think about nuclear energy? Go on. The back. Direct your question to which country you're excited to hear from.
Well, I would say this is a pretty broad question. My question is, do you think COP28 so far has been pro-nuclear, like happy, increased with nuclear? Do you want more? Do you want to hear more and get more out of the governments for nuclear?
Yeah, great question. You want to take that one, Rich?
I'd start with a positive. It's the most pro-nuclear COP I've ever been to. I mean, I've not been to them all, obviously. I'm a youth. But it's the first COP where there's more than a couple pavilions about nuclear. The fact that I can just see another pavilion about nuclear is amazing. Last year there was 2. The year before that there was just 1. So there's 2 here, and I know in the blue zone there's two or 3 more. Then obviously the pledge that we mentioned earlier, that's a huge thing. It's the first international pledge that I've heard at a COP. I think a few years ago China made a pledge to build a lot of nuclear, and other countries have had their pledges, but nothing on an international scale. So that's really pleasing to see. I think there's still a way to go. There's still an exclusion of nuclear. It's not seen as the same as renewables. In the fight against climate, it's all about reducing carbon emissions. It's not about whether you're renewable or not. It's about whether you're clean or not. And I think in the future, we'd be keen to see more of a discussion around clean energy pledges as opposed to renewable versus nuclear. We're all in the same, on the same journey, same goal to fight climate change. We should be the pledges should be unanimous across all the energies.
Right.
Yeah, I especially given the fact that the fuel supply chain is an issue in different parts of the world. It can help to incentivize investors to push that wheel along, and it will also help to enable policies to drive more nuclear technology deployment in these countries. I think I'd love to see a lot more countries sign on to the pledge, and so maybe we'll see some sign on by next week, so my fingers are crossed.
And then question behind you.
I guess my question is about safety, right? Because I know that's a major conversation that a lot of people have. I'm assuming it means that we've come a long way in terms of safety. And I'm specifically thinking about Japan and maybe the island nations as well, with sea level changes and with maybe some major storms coming along the way. Is there concerns about safety of things melting down or anything along those lines?
Yeah. So I would say, with nuclear plants, it is one of the most regulated industries, and rightfully so. I mean, it is such a powerful technology that people need to rise to the best of their ability to harness the power of the atom. What I will say with what we've seen in the 3 accidents, the most notable accidents, is that it's key to remember Japan, right? Many lost their lives, thousands lost their lives from the actual the earthquake and the tsunami. And there was faults in not preparing and rising and constructing sea walls to the height that they needed to be. So with climate change, they're constantly looking at what adaptations and mitigations do we have to enact into the plant? What is it with more severe heat weather or even cold freezes like we saw in Texas? I'm from the United States. And covering up equipment that's outside so that it isn't affected. So what I would say is that they're still looking and monitoring it, and as we know, climate change, certain places will be affected more so, and they have to take that into consideration. And with safety, people that work at plants pride themselves on the high level of safety they have. I think we just need to talk better about what happened at the accidents, lessons learned, and how they were enacted in all the plants globally. But it is a common thing. That's the highest question.
What I'd
that we
add
get.
to that is, of all the energy sources, the easiest to defend against flooding and tsunamis are the ones that are most spatially dense. And nuclear power is the most spatially dense form of energy. So, 1 small kilometre squared area is enough to power several gigawatts of clean electricity. And what that means is, with such a small area, you don't need to be building walls for miles and miles and miles. You can build smaller containment walls for if ever there are tsunamis. And that's not something you see with other more sort of spatially expansive clean energy sources, which will also be affected by sea level rise. On your question about concern, we've actually commissioned some polling of 20 countries around the world. Reports soon to come out. What we're seeing initially, which is really interesting, is, as everyone would expect, the majority of people around the world are concerned about nuclear safety. But what's really interesting is, when you dig into the data, of those, it's about 70-80% of people around the world are concerned about nuclear safety. Within those people, there is still net support for nuclear. So within everyone who's concerned about safety, they still support it more than they oppose it. More people support it than oppose. And we've been thinking, why could that be? I think the first answer we have is a bit like flying. There's a lot of people scared of flying, but they realize if they want to go the other side of the world to a climate conference, they don't really have any other option in the amount of time they have available. And I think there's a similar thing with nuclear. They realize if they want to fight climate change, what matters more is getting as much clean electricity to be generated as quickly as possible, and not the risk of a 1 in however many hundreds year sort of accident happening near where they live. The second thing is a bit like what I call the mouse in the house. So I'm scared of mice, and my girlfriend likes to joke every time I jump, but it's sort of an intrinsic fear. I know that those mice aren't dangerous to me, but I'm still scared. And I think there's an element of that with nuclear. People look at the statistics and they see that fewer than 50 people have lost their life to Chernobyl so far. No one has been seen to lose their life from the radiation in Fukushima. And they look at the numbers, and nuclear is as safe as wind and solar when you look at it on an international scale. And people are reassured by that. They still have a intrinsic fear of the idea, but they realize that that's not enough to base whether they support or oppose nuclear energy.
I'll just add the technical point from the perspective of a nuclear engineer. So on the point of safety, nuclear reactors are designed to withstand natural disasters. It's innately a part of the design. And so when we talk about Fukushima, for example, the concern there was not with the reactor design itself, because when the earthquake happened, it prompted an emergency system where the reactor shut itself down, right? The problem came when, after you shut the reactor down, fission is no longer occurring, but you still have radioactive decay going on in the core. And if you're radioactively decaying, you're still releasing heat. So if you're still releasing heat, you still need energy to cool the reactor, right? Even though it's shut down. So with Fukushima, you have external emergency cooling systems. The problem there was that the cooling systems were located in the basement. And so the tsunami came. If the tsunami came and covered up those basement emergency cooling systems, those can no longer cool the reactor. You get my drift? So there was nothing there to continually cool the reactor that was producing heat through radioactive decay, and so it just superheated basically, and that, along with some chemical reactions, allowed it to cause a hydrogen explosion, right? But innately within the design of the reactor, it's specifically designed to withstand against hurricanes, tornadoes, tsunamis, floods, you name it. I did a study where I actually created a list of all the natural disasters that have happened since nuclear power plants were built. Fukushima is the only power plant that stands out as being affected by that natural disaster, and that's primarily because the emergency systems were located in the basement. And so that is a nuclear plant design flaw, not a nuclear reactor design flaw, right? And so these are some of the things that we want to talk about when we're talking about accidents in a perspective, from a technical perspective, on exactly how they happen.
One final thing, I think it's a great question, and it's makes for good discussion. Questions about safety. I think in the last few years we've seen sort of a real stress test case for nuclear in Ukraine, where the power plant was under siege, and there's bombs going to it, and touch wood, everything's been fine so far. No loss of radiation, no loss of life from Zaporizhia, and I think what that shows is, one, these power plants are built to withstand natural disasters. They're built to withstand terrorist activity, planes crashing into them. But they're also, turns out that's strong enough to withstand bombs being directed at you. And what it also shows is the regulators in the industry, the IAEA, the international bodies that look after nuclear power plants, they were on the scene very quickly. And they made sure that things were sort of under control and there wasn't any risk. And I think that, hopefully, as time goes on, gives faith to the international community that, while they might still have that intrinsic fear, they also trust the regulator to do the right thing and to be there if ever there is a power plant in danger. Right. Any other questions?
I guess I would like to add something about nuclear safety, which I think deters a lot of people from going away from nuclear energy. One has to look at the fact that no technology is 100% safe. No technology is 100% risk-free. So with any technology, with any energy source, you have to look at what the safety performance has been. There have been a lot of fatalities in the oil and gas industry. There have been a lot of accidents in fossil power plants and so on. Compare that to the nuclear power's history for the last 60 years or so. Very, very minimal accidents, very few fatalities all over the world, not just in the US or developed countries. So you got to take a look at that and take a look at what the new technology is able to offer. The nuclear industry, I think, is the only one that I know has learned a lot from what has happened over the last several years. Fukushima, the whole industry has learned a lot and incorporated a lot of safety features. And perhaps the most exciting thing is the advanced technology and the new reactors, which have a lot of safety features that the industry has learned over the last several years and incorporated those in the new reactor designs. So that's the most exciting part. As we go forward, the safety performance is expected to significantly improve than what has been in the past. Thank you.
Any questions?
Thank you so much for that. And I'm sorry if you've already answered this question, but I want to hear your opinion about fusion power. Did you already mention it in the presentation? Because I came in sort of late. Oh, okay. Sorry.
Yeah.
Well, no, we didn't discuss it much.
No.
Because, you always hear that conversation of like, oh, fusion is 10 years away. But I think in recent, particularly this year, a lot of it has now come to the point where they think it's probable that it'll be functioning in a year, 2 years' time, particularly in Germany.
Yeah.
So
Maybe-
a very direct question, I guess, for you to answer.
Andre, introduce yourself.
Hello again, I'm Andrea. No problem. I'm from Portugal, and I've been interested in nuclear fusion since high school. And what I came to realize is that from my teachers that in my university study fusion, the president of the fusion facility in our university says that it is really great we're building fusion and it may be necessary in like 100 years, but for the next 20 we should not count on it in the way of invest too much in it and disregard the fusion. He is also in this movement, he is the godfather of our movement, let's call it in Portugal, because we have a lot to learn from him, and he's been doing this for years of educating people that fusion is awesome and it's his work, he loves it. But it's not there yet. And there's this big corporation being built in fusion that is in France, and it's called ITER. ITER is Latin for the way. It's like the way to investigate and to reach nuclear fusion right. But this facility, although it is expected to reach a gain of 10 times the energy you put in, it is not yet connected to the grid to put energy back to the grid. For now, it is a research facility. So it will work. We hope it will get to the estimated levels, but there's no way to put it back to the grid. And so, what do I want to say with this is that we're not there yet. We will keep on working on it, but for now, we have nuclear fission rights available and ready to go. Within 10 to 12 years, any country can build, around 10 to 12 years, any country can get legislation and maybe get a nuclear plant in that time frame. And within 20, 30 years, we'll be thanking those who got nuclear energy built in their countries and got through the hard work of making the legislation from the ground level and seeing what the benefit of decarbonization it gets us.
Just adding a little bit on that. So I think with any technology, it has to be demonstrated before we can access that technology commercially. Sorry, I'm Dr. Charlene Smith, a nuclear engineer. For the case of fission, it's the same for any other technology. You demonstrate it before we can commercially deploy it. ITER is a really good example of an international collaboration to demonstrate fusion technology. So what that means is that we're waiting on a step where we can say definitively that we can produce more energy than we put in. Until we get past that phase, then we can start to entertain a serious conversation about commercial fission. But it's something that has to be demonstrated first. So 1 to 2 years, I don't think that's going to happen. Very unlikely. But again, it goes back to it needs to be demonstrated. One, we do have fission power, which we have years and years of operational experience with. And so if it's a question of what firm, clean baseload power can we use to effectively displace fossil fuel energy, we use what we have on the table, because at this point we're running out of time.
The UK's perspective I could add is the government in the UK, large funder of fusion, but in their white paper on nuclear energy, they said fusion is a distant idea. They don't expect to get any economic return on it for another 50 years. The way I like to think of it, it's a bit like sort of the mission to the moon or the mission to Mars even. It's great for building a national pride in a country's engineering base, the science base. It's great at sort of developing that science further, in fusion, discovering new materials, new sort of elements of physics. But the financial benefit takes a lot longer to get. Just like, man landed on the moon, what was it, 40 years ago, but, there's not been any economic benefit from that directly. And, man's going to Mars, but, it's going to take a lot longer till we're all going there. I think the same is with fusion. It's going to take a lot of time until we can all benefit from it. And just like, I don't think we should focus all our efforts on Mars and instead focus on the planet Earth. I think the same applies with fusion. Shouldn't focus all our efforts on fusion, instead focus on what we can do to save our planet today.
Go ahead.
I apologize if you've already answered this question, but you're a network of young people focused on nuclear energy. Can you comment on if within your network you have individuals and groups inside Germany or Japan, and specifically Germany, if when you speak with your younger colleagues, are the attitudes and perspectives different? Are they evolving?